Hello all and welcome to our basic programming of PLC. So this is day 4 and in yesterday's session we were doing some basic programming, both logic gate implementation, 4 to 1 multiplexer implementation, and finally we have done a real-time door simulation experiment. Now we will familiarize some more functions in PLC first, and after that we'll do some more real examples. So let's start with that. So let's take the Logix Pro. So this is our basic experiment setup. Now here we have a programming panel where we have seen addition of rung, addition of parallel path, and uh, normally open contact, normally closed contact, then output, then output latch, and output unlatch. So the next thing is an OSR. OSR, as I have said in the last class, that is one shot register. So let's see what a one shot register is. For that, let's take this. Yeah. So this is nothing but a one shot register. So one shot register. So basically our PLC is having a scan cycle. That is, first we are taking the input input parameters, then we are executing the program, and finally we will update the outputs. So it will take some time for reading input, then executing the program, and finally writing the output. So if there is any signal coming, if any signal is taking a high low to high transition and a high to low transition in between the scan cycle, that means if we need this much time, say let this be the execution time, t execute, this be the time of execution. If any signal is taking a time which is less than this, that is if some variable, some input, any of the inputs, so any of the inputs is taking time which is less than the execution time, during the next execution the input is having the same value as in the before case before. So the PLC cannot recognize that change in input, and here we need something called a one-shot register. So let this be a one-shot register. This is OSR. So if any signal is coming, or any signal is coming for a very small interval of time, this one-shot register can register that. So this one-shot register can be used for registering that particular values, that momentary input changes can be recognized using this one-shot register. Let's see that. So let's take this one. Okay, so this is a one-shot register, so I'm just clicking and dragging it here. So we have got a one-shot register, and we will okay, usually this say this is the input and this is the one-shot register. Now what we will do is we'll give some address here, say I colon 1/0. So this address is given. Before that I'm taking the simulation, so I'm taking the IO simulator. So this is IO simulator, and we can use this one shot register to latch one particular output. So one particular output can be latch using this thing. So this output may be a bit value. So before that, I'll tell you what a bit value is. For that, I'm just right clicking the output and I'm taking that data table. So there is an option. You may not be able to see that option. There is a last option which is known as the go to data table. So I'm just clicking that go to data table. So go to data. Now you can see a table. So you can see a table here. This table is having some values. So there is a radix binary here. There is a table output here. Then some forces are there, address is there, symbol is there. That we are not interested in right now. So just click the table, scroll down menu. So you can see output, input, status, binary, timer, counter, control, integer. All these values you can see. So you just take the binary value. So this binary is nothing but B3. So as our input started from I colon 1, output started from O colon 2. Likewise, we have a binary value, binary fields, which starts from B3. So B3 colon 0 slash some value. So here ഇവിടെ നമുക്ക് double click ചെയ്ത് കഴിഞ്ഞാൽ here you can change the value. So this value can be changed. ഇവിടെ binary ആണ്. ഈ binary നമുക്ക് decimal ആക്കി മാറ്റാം. So now the value is decimal. Okay, so let's switch to binary. So these are user defined bits. So user can define the bit. So what I'm going to do is, if this input, this is considered as a momentary input. If this input is coming, I am just setting one of the bit fields. So even if the input goes low, that bit field can be accessed, or the status of that bit field can be used for registering whether that input has come and go. So B3, I'm just typing B3 colon 0 slash 0. Okay, so if this input is coming, B3 colon 0 slash 0, we'll set that. Okay, so let's download this to PLC. Then we can go online and switch this to run mode. Now you can see this OSR value. Okay, so if I'm switching this I1 colon 0 to this thing, and I'm checking that value, go to data table, and I'm switching this to binary. You can see a one has came here. So a one has one is there. So I'm switching this to decimal. Now you can see a one is here. Okay, so that is the purpose of OSR, one shot register. So this one shot register can be used. Even if I remove this, that will be there. That value will be there. So I'm switching this to binary. Yeah, that value is there. So this can be cleared using another OSR. Just I'm coming to programming mode. Then I'm going offline. Then adding another rung. So another rung is added. Then I'm just clicking this. Control C, Control V. Control V. It's not working, I think. Anyway, we'll add another thing. So another one shot register is added, and an output latch is added. Unlatch is added. So the same can be unlatched using another signal, that is I colon 1 slash 1. So another input can be used to clear the same bit field. So B3 colon 0 slash 0. Okay. So one switch is used to set the bit field value, and another switch is used to reset that value. Now I'm downloading this to PLC, and I'm going online and switching this to run mode. So now we can see that I'm going to data table, okay, and I'm selecting binary. Yeah, now it's not there. B3 colon 0 slash 0 is not there. So I'm switching this to decimal, and I'm giving an input here. Okay, well, nothing happened. I'm giving an input here. Oh, what happened? Uh, this is not working, I think. Okay, anyway, uh, so that is the purpose of OSR. This is actually not working. I don't know what happened. So that is the purpose of OSR. OSR can be used to register this particular value if the incoming signal is less than incoming signal is having a period less than the scan cycle. So that is OSR. Now we can go to another section, that is the bit. See here also you can see for bit also you can see normally open bit, normally closed bit, then output bit, bit latch, then bit unlatch, and same OSR is there. Uh, both the things can be used, but addressing, if you are using this OSR and giving the exact address, it will be acting as an OSR. That's it. Now we come to the timer. So here we can have a timer and counter settings. So let's see what a timer is. For that, I'm just switching to board. So here we are going to deal with the timers. Okay. Uh, yeah, timer. Now we have mainly two timers. One is on delay timer and another is off delay timer. So let's take an on delay timer. So on delay timer. Now this T on is known as the on delay timer, and T off is known as the off delay timer. I'll give you that figure here. So yeah, this is basically an on delay timer. Sorry. This is the figure of an on delay timer. You can see this. Here we have the provision to give an input. So an input point is there. If a high signal is coming to this particular value, we will get two outputs. One is output enable and another is output done. So this T on timer, we you say for this value, the timer value is marked as a question mark. So usually address of the timer will come here. The address starts like this: T4 colon 0 or T4 colon 1, like this. The address will go like this. And here we have a timer base. So this is the base of the timer. So this is 0.1 seconds. We can have 0.01 seconds or 1 seconds or 10 seconds depending upon the time base value the timer will run. And this preset value is the value or that much times this time base will be counted. So for example, if the time base is 0.1 second and preset value is 20. Now this zero point 0.1 second will be counted, and 0.1 second will be spared 20 times. That means you will get 20 into 0.1 seconds or 2 seconds. So this will result in a 2-second counter. And this accumulator value is the value current value, that is it starts from 0, then it after 0.1 seconds it will go to 1, then after 0.1 seconds it will go to 2, I mean, yeah, 2, 3, 4 up to 19, and after that it got reset to 0. So that is how the timer operates. Now we have two outputs, one is enable and another is done. So this will be like this. So I'll take another slide. So I'll just see, this timer will come at the output side. When you are creating a run, timer will come at the output side. Now we will give an input to the timer. Say let the input be I colon 1/0. Now this is connected to this. So whenever a high signal is coming to this particular input, the timer will get enabled. So this timer enable. So this is nothing but timer enable. This timer enable will become high. When I colon 1/0 equal to high, this T4 colon 0 slash EN, that is enable, that become high. Let this be a 0.5 a 10-second counter. So this be a 10-second counter. So after 10 seconds, when this input becomes 1 and this timer starts from this point, and after 10 seconds, this T4 colon 0 slash done, that is the timer operation is done. That, sorry, I have made a mistake. Actually, I'm sorry. This is not 0. This is 1. Okay. At the same instant when input becomes 1, timer enable will become 1. And after 10 seconds, the done bit will become high. So at this particular value, the done bit is equal to 0. But after this seconds, both enable and done will become high. So it will be like this. Suppose we have an input here. At this particular point, the input goes high. Okay. So it is continuing in the high state. It may be a 10-second counter. So the enable bit will become high at the same point. Okay. Now the done bit is actually low, and after 10 seconds, say this much be the 10-second point. Okay, this much be the 10 seconds. So this is the 10-second counter. So at accumulator value reaches 100. 10 ആണെങ്കിൽ നമ്മൾ 0.1 ബേസ് കൊടുക്കുന്നെങ്കിൽ 100 ആയിരിക്കും preset value. So accumulator value ഇവിടെ എത്തുമ്പോൾ 100 ആകും. Now this become high. Okay, done. ഇനി whenever we remove this input value, ഇപ്പോൾ 10-second counter ആണ്, 3 second ആയപ്പോൾ തന്നെ നമ്മൾ അതിൻ്റെ input value remove ചെയ്യുമെന്ന് വിചാരിക്കുക, the timer will automatically get reset. So whenever before counting the 10 second, counting the 10 seconds, whenever we remove the value, the input value, the timer will get reset automatically. ഇനി ഇതിൻ്റെ നേരെ തിരിച്ചാണ് ഓഫ് ടൈമർ. For off timer, whenever we are giving the input, the timer enable will be high and the timer done bit will be high. Timer done bitum high ആയിരിക്കും. Then after 10 seconds, the done bit will go off. അത് ഓഫായി വരും. സോ രണ്ട് രീതിയിലുള്ള ഫംഗ്ഷനും ചെയ്യാൻ വേണ്ടിയിട്ട് വി ക്യാൻ യൂസ് ദിസ്. സോ വിത്ത് ദിസ് വി ക്യാൻ പ്രാക്ടീസ് സം counter timer thing. So here I am using an input. See, this is my input. Now this input be I colon 1/0. This timer is T4 colon 0, and a time base is let the time base be 0.1 second, and the preset value be let's take a 5-second counter. So preset value be or 3-second counter, 330. So preset value is 30. Okay, now this is the counter. Then if we have to use the done bit, we have to wire another rung. So I am creating another rung here. So an input and a corresponding output. Okay, so this input is nothing but the done status of the counter. So T4 colon 0, that is the timer, and its status, that is the done status, that is DN, done. Okay, that is taken as an input. Now here we have a lamp. Let that be O colon 2/1, and I'm giving another value that is nothing but the enable bit. So enable one input and one output. This is T4 colon 0/EN, EN for enable, and I'm giving another value here O colon 2/0. So the first LED, here is for the enable bit. Whenever I give an input to the high input to the timer, the timer starts its operation, and at the same time the enable bit will become high. Here we have designed a 3-second timer. So after 3 seconds, both the enable will remain high, and after 3 seconds the done bit will become high. So let's do this. Let's download this to PLC, and I'm going online. Okay, and switching this to run mode. So now I'm giving the high signal to the timer. See, at the very moment I gave, yeah, after 3 seconds we have got this thing. So I'm disabling this. So whenever I remove this, the value, the timer got reset. Now I'm giving this again, so you can see this. Maybe the time exact 3 second may not be here. Why? Because this is a software based PLC program. But for hardware PLC programs, the 3 second will be exactly 3 seconds. So here I can adjust the scan cycle and vary the time. That is because you may not be able to exactly measure 3 seconds. So let's see, 1, 2, and 3. Yeah, almost same. So that is the T on timer. Now I can change this preset value. You can also see the accumulator value. The accumulator value is increasing, and after reaching, yeah, becomes 29, 30, it will become 0. So when I am resetting this, the accumulator value got preset to 0. Now I'm just switching this to program, and I'm changing the preset value. Let this be 100. So 10-second time. Okay. Then I'm downloading again this to PLC so as to make the change, reflect the change here. So switching this to run mode, and I'm giving an input to the timer. Yeah, it's counting. Yeah, and at this particular moment, now it's 6 seconds. I'm removing this. See, so the entire thing, the entire timer got reset. So that is the T on timer. Okay, now I'm again switching this to program mode. I'm right clicking this, Yeah, sorry, I cannot change the timer T on to T off from this. So what I'm doing is I'm going to delete this. So I'm going offline, and I'm going to delete this particular timer. Yeah, and I'm going to add another T off timer. So now T off timer is got added. Now I'm giving the same timer address. Yeah, and the say 5-second preset value. Sorry, 50. So that the time total time will be 5 seconds. So that done and enable bit is there. So let's see. I'm downloading this to PLC. Okay, and I'm going online, switching this to run mode. Okay, I'm giving input. See, done is also there. Then after, what happened? Yeah, after removing that, so after removing the signal, it will go off. So initially, when a high signal is fed to the timer, T off timer, when a high signal is fed to the T off timer, the timer will be in off state. So when I'm removing that input signal, when I'm removing this high input signal, so that timer will start its timing operation, and after 10 seconds, here 5 seconds, the timer will give a low value at the done bit. So I'm just, so this is the input to the timer. T off timer is nothing but an active low signal. So when a low signal is given, it activates the timer. So now the timer is get activated, it's counting, accumulator value is changing. Yeah, finally the done bit will become 0. So that is the T off timer. So with this we can do some real problem. So uh, I'm going offline. So the problem is this. So repeat cycling problem. So an output pulses on and quickly off at a constant preset time interval. How can that be done? So an output pulses on and off. നമുക്ക് ഒരു പൾസ് ഓൺ ആൻഡ് ഓഫ് എങ്ങനെ ചെയ്യാൻ പറ്റും, അതെങ്ങനെ ചെയ്യാൻ പറ്റുമെന്ന് നമുക്ക് നോക്കാം. ബിഫോർ ദാറ്റ് ലെറ്റ്സ് ഡു സം വർക്ക്. Okay, let's take another page. So this is a repeat cycling problem. So repeat cycling, that means an output pulses on and off in a regular interval at a constant preset interval. An output pulses on and off. It is nothing but some circuit like an stable multivibrator, which gives an on signal, an off signal, an on signal, an off signal, on signal, off signal, like this. So this T on period and T off period can be exactly programmed. So by adjusting the duty cycle, by adjusting different values for this particular thing, we can make this T on and T off. Okay, so let's do that. So for turning it on, we have to have one timer, and for turning it off, we have to have another timer. Let's do that. So let's go to the uh, programming window. So I'm just deleting this circuits. Okay, so I'm adding one T on timer and one T off timer. Sorry, I'm creating another run. So additional run is created, and I'm adding a T off timer. So one is to turn on something, another is to turn off something. Okay. Now, in order to do a cycling process, what we have to do is, that is, again we have to we are going to the board. So for cycling operation, cycle operation, what we need is, say for any programming language, we have some lines of code. Say let this be line 1, line 2, likewise. Say let's we have 50 lines of code, and if we have to do this, we have to loop this. The looping must be done for continuously executing this line. So in PLC programming, what we need, or what we use instead of looping, is known as the interlocking. So interlocking means after executing one line, we are switching back to the initial. That is what is known as the interlocking. So here also we need some interlocking. So let's see how the interlocking can be done. So let's take this. So here we have a T on and T off timer. So both are T offs. Sorry. So I'm taking a T on. So first do the T on timer. So the T on timer can be uh, turned on. So this be, yeah, T4:0. It's a 5-second timer. Let's change that to 3 seconds. So this is a 3-second counter, or 2 seconds. This is a 2-second 2-second counter. So the turn on period will be 2 seconds. Okay. So when this counter, timer reaches 2 seconds, 2 second എത്തിക്കഴിഞ്ഞു കഴിഞ്ഞാൽ, we have to start the off timer. Okay, we have to start the off timer. So this T on and T off must be done in a sequential manner. So for that, what I'm going to do is, I'm just using the enable. See here we have a, yeah, normally this thing, yeah, enable of T4. So this is T4:0/enable. So this enable of this thing can be used as a trigger to this. Okay. അപ്പോൾ നമ്മൾ ഇതിൻ്റെ എനേബിൾ ഹൈ ആയിരിക്കുമ്പോൾ, ഫസ്റ്റ് ടൈമറിൻ്റെ എനേബിൾ ഹൈ ആയിരിക്കുമ്പോൾ, നമ്മുടെ സെക്കൻഡ് ടൈമർ, ടി ഓഫ് ടൈമർ ഡീആക്ടിവേറ്റഡ് ആയിരിക്കും. ഓക്കെ, കാരണം ടി ഓഫ് ടൈമറിന് ഒരു ലോ സിഗ്നൽ കൊടുത്താലേ നമുക്കൊരു ഹൈ വാല്യൂ കിട്ടുള്ളൂ. ഒരു ലോ സിഗ്നൽ കൊടുത്താലേ ഒരു ഹൈ വാല്യൂ നമുക്ക് കിട്ടുള്ളൂ. സോ ടി ഓൺ ടൈമർ ഓൺ ആയിരിക്കുമ്പോൾ ടി ഓഫ് ടൈമർ ഓഫ് ആയിരിക്കും. ഓക്കെ, ഈ ടി ഓൺ ടൈമർ ഓഫ് ആയിരിക്കുന്നു എന്ന് വിചാരിക്കുക. അതായത് ഇതിൻ്റെ എനേബിൾ ലോ ആണ്. ഇതിൻ്റെ എനേബിൾ ലോ ആകുമ്പോൾ നമ്മൾ ടി ഓഫ് ടൈമറിനെ ട്രിഗർ ചെയ്യുന്നു. ടി ഓഫ് ടൈമറിനെ ട്രിഗർ ചെയ്തിട്ട്, അപ്പോൾ ടി ഓഫ് ടൈമറിനെ ട്രിഗർ ചെയ്ത് കഴിഞ്ഞാൽ ഈ ടി ഓഫ് ടൈമറിൻ്റെ എനേബിൾ ഹൈ ആയിരിക്കും, അതിൻ്റെ ഡണ്ണും ഹൈ ആയിരിക്കും. ഒരു സേ ലെറ്റ് ദിസ് ബി T4:1. Okay, and the preset be same thing, 20. Okay, so 2 seconds. So after 2 seconds, this done will go low. ഈ ഡൺ ലോ ആയിരിക്കും. അപ്പോൾ ഈ ഡൺ ലോ ആയിരിക്കുമ്പോൾ നമ്മൾ ഇതിനെ വീണ്ടും റീസ്റ്റാർട്ട് ചെയ്യും. സോ ഇത് ലോ ആയിരിക്കുമ്പോൾ റീസ്റ്റാർട്ട് ചെയ്യണമെങ്കിൽ നമ്മൾ ഇത് കൊടുക്കണം. സോ T4:0/done. Okay, so this done can be used, and also we need to use one switch for enabling this. ഒരു സ്വിച്ച് വേണം ഇതിനെ എനേബിൾ ചെയ്യിക്കാൻ. ആ സ്വിച്ച് നമുക്ക് ഇവിടുന്ന് കൊടുക്കാം. സോ ആദ്യം ഓൺ ആക്കാൻ വേണ്ടി നമ്മളിവിടെ ഒരു സ്വിച്ച് കൊടുക്കുന്നു. ദാറ്റ് സ്വിച്ച് ഇസ് I:1/0. ഒരു സ്വിച്ച് ഉണ്ടെങ്കിൽ മാത്രമേ നമുക്ക് വർക്ക് ചെയ്യുള്ളൂ. സ്വിച്ച് ഇല്ലെങ്കിൽ ഇത് വർക്ക് ചെയ്യില്ല. ലൈക്ക് വൈസ്. So first we are enabling this, and this thing is high. So you will get you will activate this thing, and ഇതിൻ്റെ enabler വന്നു കഴിയുമ്പോൾ നമുക്കിവിടെ എന്ത് കിട്ടും? നമുക്കിവിടെ ഇത് ഓഫ് ആയിരിക്കും. ഇതിൻ്റെ enable എപ്പോൾ നമ്മൾ 0 ആക്കുന്നോ അപ്പോൾ മാത്രം ഇത് സ്റ്റാർട്ട് ചെയ്യും. സോ ലെറ്റ്സ് ഡു ദിസ്, ആൻഡ് വി ഹാവ് ടു give the done. നമുക്ക് ഔട്ട്പുട്ട് കാണാൻ വേണ്ടി ഒരു സാധനം കൂടെ നമ്മൾ ചെയ്യണം. അത് നമ്മളിവിടെ കൊടുക്കുകയാണ്. So let's do this. I think some problem is there in the circuitry. Anyway, let's see. So this is T4:0/done. Okay, and this is one LED, that is O:2/0. So let's download this to PLC. So I'm downloading this to PLC, and I'm going online and switching this to run mode. Okay, and I'm just doing this. What happened? Yeah, it's giving some output, but I think some problem is there. Let's see what is the problem. Okay, momentarily it becomes this thing. So what I can do is okay, I'm just giving this as an assignment to you, so we don't have much time to rectify this problem. So we'll switch to the next thing. So actually we need two timers, a T on timer and a T off timer, to make these two switch over. So I'm giving this to you as an assignment. You can do it on your own. And anyway, I'll give you the updated result in the starting of the next session. So with this, I am winding up the timer section, and without losing much time, we are going to another thing, that is, I'm just going offline. So this is the timer and counter. So we have a counter section here. So here you can see a count up. So before that, I'm just saving this. I'm saving this as error, so that I can give you the updated result tomorrow. Yeah. So I'm just deleting this thing, and we are going to the count up. So this is count up. So we have let's say one input is here. Yeah, one input is here, and we have a count. I'm giving this input as I:1/0. So this is I:1/0, and this counter. So I'm right clicking this, going to data table. So this counter is C5. So C5 is the counter. So I'm taking the C5:0 as the first counter. Now let's say the preset value be 10. Okay, now I'm just downloading this to PLC, and with execution I'll explain the working of this. So going online and running, switching this to run mode. So I'm giving the input here. See, whenever I have given an input, whenever I gave an input to the count up, the accumulator value is incremented by 1. Now I am removing this, so there is no change. Now the accumulator value is 1. Now I am again giving another input, so the accumulator value changed to 2. Now again I am removing this value. Then again I am giving another input, then removing that. Again another input, removing that. So we can see the accumulator value is incremented by 1 at each incoming pulses. So it is just counting the incoming pulses to the up counter, and when it reaches 10, so the preset value and accumulator value both are equal. When these two values become equal, now we have got a done bit. So now you can see the done bit is high. Now again I am giving another input. See, it is incrementing, but the value is done. Okay, so it counts minimum 10 values. So അതിന് മുകളിൽ വന്നാൽ we have to actually reset the counter. കൗണ്ടറിനെ നമ്മൾ റീസെറ്റ് ചെയ്യണം. So this is actually used for counting the number of people inside a room. നമ്മൾ റൂമിലേക്ക് കടക്കുന്നതും റൂമിൽ നിന്ന് വെളിയിലേക്ക് വരുന്നതുമായിട്ട് രണ്ട് സെൻസേഴ്സ് വെച്ചിട്ടുണ്ടാവും. One sensor is actually counting up and another sensor is actually counting down. So if a person enters the room, the up counter will get activated, and it counts or it increments the accumulator value. And when the person leaves the room, what happens is the countdown timer will get activated and it will decrement the accumulator value by 1. So let's do that also. So I'm going offline and I'm adding another timer here. So a run and also a bit and a timer. So this is a down timer. Now ഇത് നമ്മൾ പുറത്തേക്ക് ഇറങ്ങുന്ന സെൻസറിന്റെ വാല്യൂ വേറെ ഒന്നാണ് കൊടുക്കുന്നത് 1:1. Now this is the same counter, that is C5:0. Okay, yeah. Now one sensor value is actually incrementing the counter value by 1, and another is decrementing the counter value by 1. So when you are right clicking this and go to edit table, now you can see each and every values. See, this is counter 50 accumulator value and preset value. Then count up, count down, done, overflow, all these things are there. So I'm not looking into this. So just download this to PLC and I'm going online and switching this to run mode. Yeah, now if I'm giving a low value, see, now the accumulator value is decrementing. See, the accumulator value is decrementing. See, you can see this. Okay, now the accumulator value is incrementing. So when the when a person enters the room, it increments the counter. ഇവിടെ നമ്മൾ രണ്ടും ഒരേ കൗണ്ടറിന്റെ അഡ്രസ്സ് കൊടുത്തിരിക്കുന്ന കാരണം ഒരു കൗണ്ടർ തന്നെ വരും. ഇനി നമ്മൾ രണ്ട് കൗണ്ടർ ആണ് ഉപയോഗിക്കുന്നതെങ്കിൽ യു ക്യാൻ ഹാവ് minus of both the counter values. So അത് നമുക്കൊന്ന് നോക്കാം. So for that I'm just going offline. ഇവിടെ ഞാൻ നിങ്ങൾക്ക് വേറൊരു സാധനം, വേറൊരു ഇൻസ്ട്രക്ഷൻ നിങ്ങൾക്ക് ഫെമിലറൈസ് ചെയ്തു തരാം. Say this count up is 5:0 and count down is 5:1. Let this be like this. Okay, now the preset value is let the preset value be 100. Now the accumulator value, I'm changing that to 0. Okay, so that's it. Now what I'm going to do is see, I'm going to uh, take the let's say math. Okay, math value. Okay, so I'm going to subtract these two values. Okay, subtract these two values, and this is the source. Source is nothing but C5 colon 0 point. So here right click this and go to it. Preset is the ACC is the accumulator value. So ഇതിൻ്റെ C5ൻ്റെ accumulator, that is ACC. So that is accumulator value of C5, and this is sorry, before that I'm going to change this down counter to up counter. അപ്പോൾ ആളുകളുടെ നമ്പർ രണ്ട് സ്ഥലത്തും നമ്മൾ കൂടുതലാണ് വരുന്നത്, എന്നിട്ട് അതിൻ്റെ ഡിഫറൻസ് ആണ് നമ്മൾ എടുക്കാൻ പോകുന്നത്. സോ അപ്പ് ചെയ്യുന്ന ആൾക്കാരുടെ ഒരു കൗണ്ട് വരും, അത് ഇൻക്രിമെൻ്റ് ചെയ്ത് പോകും. അതേപോലെ റൂമിൽ നിന്ന് വെളിയിലേക്ക് ഇറങ്ങുന്ന ആൾക്കാരുടെ കൗണ്ടും ഇൻക്രിമെൻ്റ് ചെയ്താണ് പോകുന്നത്. അതുകൊണ്ട് വി ഹാവ് ടു യൂസ് ദ അപ്പ് കൗണ്ടർ ഓൾസോ. ഹിയർ ഓൾസോ വി ഹാവ് ടു യൂസ് ദ അപ്പ് കൗണ്ടർ. സോ C6,0 colon 0 and preset value is 100. Now നമ്മൾ അപ്പിൽ നിന്ന് ഇത് see, this is edit symbol entering room. So this is entering room. Okay, this is C6. Oh sorry, 1. Yeah, so this is leaving room. Edit symbol leaving room. So entering minus leaving ആണ് നമുക്ക് എപ്പോഴും എത്ര ആൾക്കാർ റൂമിൽ ഉണ്ടെന്നുള്ളത് അറിയുന്നത്. So entering minus leaving will be the total number of people inside the room. So here the source B is C5 colon 1 dot ACC, that is the accumulator value, and the destination, here I am giving the destination address as see ഇവിടെ നിങ്ങൾക്ക് കാണാൻ പറ്റും. Okay, leave it. So you just right click this, go to data table. Now data table നിങ്ങൾക്ക് finally you can see one N7, that is the integer value N7. So N7 colon 0, ഈ വാല്യൂയിലേക്കാണ് ഞാൻ എത്ര പേര് ബാലൻസ് ഉണ്ടെന്നുള്ളത് മൂവ് ചെയ്യാൻ പോകുന്നത്. ഇത് നമുക്ക് ഇൻഡിജർ വാല്യൂ, ഈ N എന്ന് പറയുന്നത് ഇൻഡിജർ വാല്യൂ സ്റ്റോർ ചെയ്ത് വെക്കാൻ പറ്റുന്ന കുറച്ച് ലൊക്കേഷനുകളാണ്. അത് നമ്മൾ സാധാരണഗതിയിൽ അനലോഗ് ഡിസൈൻ ചെയ്യുമ്പോഴാണ് സാധാരണഗതിയിൽ ഈ ഡെസിമൽ വാല്യൂസ് അല്ലെങ്കിൽ ഇൻഡിജർ വാല്യൂസ് സ്റ്റോർ ചെയ്ത് വെക്കുന്നത്. സോ അത് നമുക്ക് നോക്കാം. സോ N7 colon 0യിലേക്കാണ് ഞാൻ ഫസ്റ്റ് വാല്യൂ സെൻഡ് ചെയ്യാൻ പോകുന്നത്. Okay, so this destination is N7 colon 0. Okay, now I am going to download this to PLC. So downloading this to PLC, and എപ്പോഴും പറയുന്ന പോലെ തന്നെ going online and run mode. Okay, see now the N7 value is 0. Now I am going to add, see 1 minus 0 is 1. See, now the accumulator value in the first timer is 3 and second timer is 0. So you will get 3. It's 3 only. Now I am incrementing this. See, now the result is 2. So you right click this, go to table and switch this to N7 and see decimal. Now you can see N7 is equal to 2. അപ്പോൾ നമുക്ക് ഈ നമ്മുടെ ഇൻറ്റിജർ ഫീൽഡിൽ വി ക്യാൻ സീ ദ ഇൻറ്റിജർ ടേബിൾ. സോ ഇൻറ്റിജർ ഫീൽഡിൽ നമുക്ക് കാണാൻ പറ്റും നമ്മളുടെ ഡെസ്റ്റിനേഷൻ വാല്യൂ 2 ആയി. ഇതേപോലെ നമുക്ക് രണ്ട് ഡിഫറെൻറ്റ് ടൈമേഴ്സ് ഉപയോഗിച്ചിട്ട് ഇതിനെ ചെയ്യാം. സോറി, നോട്ട് ടൈമർ, കൗണ്ടർ. ടൈമറും കൗണ്ടറും നമുക്ക് തിരിഞ്ഞു പോകുമെങ്കിലും ടൈമർ എന്ന് പറഞ്ഞാൽ ഒരു ടൈം ബേസ് ജനറേറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ടാണ്, അല്ലെങ്കിൽ ഒരു ഇത്ര ടൈം നമ്മൾ വെക്കാൻ വേണ്ടിയിട്ടാണ് ടൈമർ ഉപയോഗിക്കുന്നത്. കൗണ്ടർ എന്ന് പറഞ്ഞാൽ വരുന്ന ഇൻകമിംഗ് പൾസിനെ കൗണ്ട് ചെയ്യാനുള്ളതാണ്, എത്ര പൾസ് വന്നു എന്നറിയാനുള്ളതാണ് കൗണ്ടർ. Okay, so that is the difference between timer and counter. So now this is a setup to find out the number of persons inside a room. So we have one sensor for counting persons coming towards the room and another sensor for counting persons away from the room. So ഇത് രണ്ടും അപ്പോൾ number of persons crossing that counter അനുസരിച്ച് കൗണ്ട് വാല്യൂ ഇൻക്രിമെന്റ് ചെയ്തുകൊണ്ടിരിക്കും. സോ in entering minus leaving will give you the exact number of people inside the room. So that is the timer and counter. So this is the main contents in this in today's lecture, and I'll just give you another simulation. So we'll see this simulation in detail tomorrow, but I'll just give a simulation for this so that you will get some interest. So I'm going offline. Yeah, and I'm opening a program. So here a C low program is there. Yeah, so this is a program. നമ്മൾ സി പ്രോഗ്രാമിംഗ് ഒക്കെ ചെയ്യുമ്പോൾ നിങ്ങൾക്ക് ഓരോ ലൈൻ ഓഫ് കോഡിനും സൈഡിൽ കമൻറ്റ് ചെയ്യാൻ പറ്റും. ഓരോ ഇൻപുട്ട് വേരിയബിളിനെ ഔട്ട്പുട്ട് വേരിയബിളിനെയൊക്കെ നമുക്ക് പേര് കൊടുക്കാൻ പറ്റും. വേരിയബിൾ നെയിംസ് അസൈൻ ചെയ്യാൻ പറ്റും. ഓൾ ദോസ് തിങ്സ് ക്യാൻ ബി ഡൺ. ലൈക്ക് വൈസ് ഹിയർ ഓൾസോ വി ക്യാൻ ഹാവ് ദാറ്റ് ഫെസിലിറ്റി. You can give variable names and you can also comment by adding some boxes here. So this is an example simulation, silo simulation, demonstrating continuous mode of operation. So this is a continuous mode of operation, that is we have incorporated some interlocks here. എന്താണ് നമുക്ക് നാളെ നോക്കാം. But I'll just run this. So for that I'm just downloading this to PLC. So here you can see a conveyor is there, a motor is here, a proximity sensor is here, then a level sensor is here. Here we have a reservoir. From this some material is coming out of the reservoir through the solenoid valve. These are some boxes. So our objective is to fill the box, and after filling the box we will cut off the solenoid valve and we will pick the box out of the vicinity of this level sensor or the reservoir. So another box will come. Likewise this process will continue, it will go on. Okay, so I'm downloading this to PLC. I think I've already downloaded. Yeah, and I'm switching online and run mode. Okay, now I'm just pressing this start button. See, now you can see, yeah, it's filling, and after completing that box will go, another box will come, and after filling that will go, another box will come. So this is a simple automation, and using this you can have an n number of automations here, but if you are using a trial version, you can only use for 15 days, and you may not be able to do much simulations, but IO simulation is enough for beginners. IO simulation is enough. You can have different problem statements from the internet, and you can work it on so that you'll get a feel of PLC programming. So this is the main content in today's lecture. So in the next lecture we'll begin with the timer operation. So I've given that as an assignment for you because of the time constraints. So parallelly I'll again work it on, and I'll show you how that is working. And after that, after finishing the timer operation, we will come to this, and I'll start from the beginning, and I'll tell you how this can be done in a cyclic manner. So that's it. That's all for today. So I hope you have got some new things, some takeaway points from this lecture. And I thank you for watching this, and a very good night to all of you. Thank you.